video is the training for the Epilog Mini Laser. The laser is laid out with an X and a Y. The size of this particular laser is 1 foot in the Y and 2 foot in the X. This is a little bit of a smaller area for a laser, but here at ASU we're finding it does pretty much almost everything we need. There are much larger lasers. What I'm holding here is the etching surface that we can set inside the laser. They use this for etching so that your part can sit flat on the surface. I don't think it's important to see for the camera down here, but there's one that looks like a honeycomb, same type of a surface, that has holes all the way through. That's the vector cut because it allows the laser to cut through the material. Laser is nothing more than a hot light that bounces through mirrors and creates intense heat on the material to either etch or cut. And whether you do one or the other is controlled by the computer software itself. Okay, using the laser itself is very simple. You put your material in and hit go. It really is that simple after you have it set up correctly in the software. So understanding the software on the laser and doing the correct beginning work is everything on a laser. People always ask me, what file format do I need to bring their information in? And the answer is a DXF file. If you look on SolidWorks and Rhino, I think many programs will have save as DXF. What that is lines that these softwares, I say these, there's CorelDRAW, there's Illustrator, we use CorelDRAW. These softwares recognize DXF files as what's called a vector line. Quick difference between vector and pixel is a pixel is dots, and a vector is a line, really infinitely small, but it's a line. And that's what the computer needs to see. So let's say you're using SolidWorks and you have maybe some kind of a gear. What you would do is the gear, let's say the gear's at an isometric view, you would do a normal to, so you're looking straight at it. If it's skewed when you save it, your DXF will also be skewed. So you want to make sure you're looking right at your profile or contour, then save as DXF. That will create a new file, exactly the lines of your gear, that's a vector that you will bring in a jump drive into the lab. Here on this computer, and what we're using in the lab, because ASU has a license, is CorelDRAW. You would locate on the computer and open CorelDRAW. Once you open up CorelDRAW, it's important to set up your environment correctly. And what I mean by that is, whatever size piece you're using needs to be the same size as your artboard here. This video, I'm not going to have you zoom in on every little pull down menu. I want to just tell you the basics so that when you come here you can figure it out yourself. But you know, file, open, new, and it will ask you what size is your artboard. And you take a caliper or some kind of a ruler and measure your piece. This piece it was 12 by 12. We've lopped a little off, so I measured from the end of this plastic to the top 12 by 11. So when I did file new, I set in 12 inches in the Y and 11 in the X. And that is how my graphic now is. So we are going to cut today. It's almost like a keychain kind of flag. Why did we pick this? Because it does two things that we've discussed already. It does a vector cut, and it etches in. Sheldon, by the way, who's one of our ASU lab techs over there. Etching vector cut combination, and I'll show you the difference of that in the file. If you could come back to that image. You can see the outer edge. Now, you don't need to zoom in on it, but the width of those lines is hairline, and you can set that through Object Properties under Edit. Object Properties, click on the line you want to cut and make sure you choose Width, Hairline. That's an infinite vector cutting line. So the outer line's hairline. Now when we click on the we're gonna etch Arizona State University. This is not hairline. This is just the regular font. The laser will automatically know the difference. It knows anything that's not hairline is an etch, anything that is hairline is a vector cut, so it's all in this one file together. Another thing, Since I have my artboard 12 by 11, I put it in the upper right hand corner in this case, and if we look at our plastic, if you get a good shot of that, we're aiming for this upper right corner. Okay, so now we have our vector set up with hairline and our text set up for etching. We now are ready to print, except for we have to set our laser settings correctly. File, print setup. It should say Epilogue Engraver as the chosen printer. By the way, this is just a printer. It's really just like something you would print on a piece of paper, but we're using a laser. Then preferences. This is the magic screen. This is where really all of your control and decisions are made. Here you would say, it's asking raster, which is etching, vector, or combined. Well, what's our file? It's combined. We're doing both. We have an area down here that says autofocus or center engraving. Well, I let the cat out of the bag a little bit about center engraving. Means that we can direct where the center of our file is. By unchecking that, the artwork itself will tell you where this image will be cut or etched. Autofocus means the machine will come over, touch the material, and set its focal length automatically. You use that almost 99% of the time. The reason you might do a manual focus is if you had a valley or some kind of a pocket that you needed to get into at the bottom. Piece size. This is extremely important. Your piece size must match your artwork. We have raster speed or etching speed settings, and we have vector settings. How do I get those? We have posted on our board on the wall, you don't need to film it, but on our wall is a printout, and we also have a book here in the desk of a chart where you would look up your material. We're using an acrylic, so you would look up acrylic, and you would also look up the thickness, and from that you're going to get your settings. And I'm going to ask Sheldon to aid me. So Sheldon, for etching or rastering, what's our speed for acrylic?
The speed is 100.
So I'm going to type in 100 for the speed. Okay.
And the power is 35.
35. Speed, and maybe you can see my hand, speed is how fast it goes back and forth. The slower the speed actually burns more because this hot light is it's almost like holding a lighter on your arm. If you go slower, you're going to burn more. Then the power is just the intensity of the beam. 35% of it's 50 watt. Okay, what is our vector setting?
The speed for the vector cutting is 15.
15. Okay, it's already.
The power is 100.
Okay.
And the frequency is 5,000.
Frequency. This beam is like a needle on a sewing machine. So the faster it cuts, the faster the needle goes. These settings are recommended for this material. You may find for your material or what you're trying to do, you may change these a little, but this is a good guideline. One thing I forgot to do for the etching was called image dithering, or there's different types of dots. Etching is dots. And Floyd Steinberg is one I like. It's a very fine dot. Takes a little longer. If you're just doing a name tag, you may not pick this. We're going to in this case. Alright, so we review. Autofocus, no center engraving because we want the artwork to decide where the image is. We're doing a combined vector and raster. For the etching settings from our chart, from knowing acrylic, we have our speed and power. And then from the thickness in our chart for acrylic, we have our speed, power, and frequency, and we're ready to cut. Push it to the upper left corner. If you're sloppy, you're going to be off. So upper left corner, 0 to just short of 12, which is we measured it earlier. And you can see this is the honeycomb vector table that we had discussed earlier that allows the beam to cut entirely through a piece. Here are your mirrors. The laser itself is a CO2 gas laser that pushes out our beam. There's a mirror that it reflects off, bounces down these mirrors and focuses it, almost like a magnifying glass burning ants is how this works. That's why the focal length is very important. If you're at the wrong point, it won't have its heat. There's also this silver tube. And what that is called an air assist. The laser itself uses a blower to suck all the air out of this environment for a couple reasons: to get rid of dust and to get rid of any bad gases that some materials can make. We are ready to cut. I'm going to shut this. Okay, Sheldon's going to turn on our blower. It has a 4-inch dryer tube that's going to suck the air to the outside. You do want to vent to the outside. Of course, you don't want to breathe it back inside the room. Okay, Sheldon's going to turn on the blower. We also want to turn on our air assist pump. Little switch right here. Okay, we're going to go to our software. File, print, because we already did the print setup. Print. Sends over our file, and we hit go. And there it goes. Starts with the etching. You start with the etching because you do not want your piece to move when you start your etching process. So let's see what we have. Now, this is what Sheldon was saying. Because I messed with this file, there's these little pieces here. These little parts of the flag were supposed to be etched. Well, I vector cut them because I changed them to a hairline. So you can see that's actually good. I'm glad that happened because you can see that it really changes the results. Now, of course, I could use some kind of a glue and put that back together. But those little lines right there were supposed to be supposed to be etched. But there you go. That's a vector cut and an etch, and really that's about 95% of everything you do on a laser is something like this type of job.